So here I have already populated the attributes of each entities for the customer order and product. So it would not take us some time, no, to fill up the attributes of its entities. So here we have your customer. We have customer ID, first name, last name, street, city, zip, and phone for the attributes. And here we have the attributes for the order as follows. So we have order number, customer ID, customer name, the street, the city, the state, the zip, and ship date. And for the product entity, we have the product ID, quantity, and product type. Take note that I have chosen this figure with the third column so that I could actually include the type of the variable for the attributes. Like for example, here I have customer ID. The type of this one is integer. Usually, and by default in the database table, for example, in SQL, you usually declare the type, no, by default of incrementing by one, no, by default. Okay, so first name is a variable character of length 30, length 30, 30, 30 for the next attributes, last name, street, and city, and integer for zip and phone. The type of the variable type for zip and phone are the same. They are integer, whole number. No? So I don't think I have a phone number of 99.94. No, so no, just kidding. We have an integer type. Okay. So likewise, you need to declare also the variable type of each variable of the attributes. And take note of this ship date. There is also what we call a date type variable. Okay. Likewise with the product ID. So now let's talk about the cardinality and or the interaction, the relationship between the entities. Let's start up with what we call the relationship of the customer and order. So the best way to think of the relationship is thinking of the maximum. And you must consider first the one-way direction first. Like for example, from customer to order, no, we can draw actually a line. No, there are dots here. We could actually click once it is highlighted with the dot or shaded dot. Then you could actually, sorry, I just need to click it. Okay, click. I'm sorry, it's not working. I'm sorry, why? I had a problem here with my pad. Okay, gotcha there. Just need to left click and click that dot. Then let's link it to order. There you go. So there's a funky notations on the both sides of this line. So um, we could actually change the annotations on these sides, no, or the both sides of this line. Let's consider first the way from the customer to order. Now, a customer may exist, um, but can have no orders or what we call the zero orders or as many orders as he wants. So the cardinality then would be zero order or as many order he or she wants. So in this case, I could just choose a zero and many. This will be the zero and many for this option. Sorry, I'm not. Okay, let's try it again. Zero, many. Yeah. And then vice versa, going back from order to customer. So an an order, um, an order number, for example, an order can only have one and only one customer. That is uh, every customer because has its own customer ID and they have their own order. So it means to say an order may take only or is taken only in one and only one customer. So there would be only one and only one customer for a certain order. Okay. So there you go. Mm-hmm. I haven't clicked this one yet. Yeah. And then one and only one. So there you go. So that's how simple we could actually include the line here to represent the uh, relationship. Take note when you choose the cardinality notation, you think of the minimum and maximum. Like for example, a customer minimum amount of order is he or she could actually consider zero order, or in a maximum point he or she could actually have many orders, but in an order there could only be one and only one customer. Okay, so let's okay, so let me just fast forward, guys. I need to pee. I'm sorry. Okay, so again, so I have drawn a line here, so let's consider the relationship. So let's consider first the reverse way. mm, a product can be a part of no order, so meaning that that product has no order, or a product can be a part of many orders, meaning to say I have many orders and those orders may have that product. Or a product in the other way around, product may be a part of no order. So the minimum there is no, so zero, and then the product can be part of the many orders, so zero or many. So we need to highlight this first. So can be where's that notation? Okay, here you go. Okay, so a product can be a part of zero order or many orders. Okay, there you go. Then the reverse process, um, of course, an order may have many products, and at least there should be a one product because it is existing as an order. No, when there is an order, at least there is at least one order or many order. So the cardinality notation would be one, at least one product or up to many product in a certain order. So that's why this is the one to many, and this is a zero product part of an order. There's an order but a certain product's not there, or a product may be part of the many orders. So this is zero to many. Okay, so that's how we define the relationship. No? So okay, so now we have considered the cardinality, or how the entities are related to each other. So let's now uh, go to this, what we call the first column, consider the key. So we have different types of keys. No? So we have the first one, the primary key. It is an attribute that uniquely identify a record in a certain record table. So any field that would actually tell a certain record that is unique from the other records. So that is we will be using primary key to tell that is actually a record is a unique record. No? So rules in identifying the primary key, it should be unique and never changing, and cannot be a null value. So because if it's a null value or zero value, you don't know a certain a record. So it should be with a value and it is unique, and it is not advisable to be changing because it would be vague or ambiguous if a certain identity or say or customer, for example, is has a many account or ID. So that's a primary key. So let's move to the customer table. Again, so here's the customer table. Let's identify the attributes or the field that is considered as the primary key. In this case, let's try first the first name. So the first name can appear actually many times or one or many times in this column because a customer may have order 2 days ago and then decided to get another order. So it's it's not unique in this column because it is repeating or redundant. Okay, so likewise with the name and street because that uh, in street there may be two persons. Yes, they have a customer ID, but you have the same address where they live. So again, that is not unique. Again, likewise with the city, zip and phone. So what identifies a certain record in these rows is actually the customer ID. So there could never be another 30003 among the thousands or even millions of records. No? So that would be our primary key. So we could actually consider it now in our okay. So would be our PK or primary key. So let me just increase the size of this. Then we could actually uh, delete all those attributes that cannot be at the same time primary key. So let's delete this. Delete, 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 and delete, and delete. So let's go to the order entity or order table. So so let's go back to our slides and the order table. So customer ID. So, let's we know the fact that we could have I think same ship date, for example, in this case for two different orders. So ship date cannot be the primary key for order, and zip as well. Same thing with to state and city because Springfield and Springfield just the same. That's not unique. Likewise, there can be other states or many states in this column, and likewise with the street as well as the customer. The order number would be the say the customer ID. So let's identify the primary key, which is unique and cannot be null and never changing. Okay, In this case, in a certain order can be there can be many orders at different dates uh, ordered by a certain person. Like for example, let's check. Yeah, John Smith and John Smith. Okay, that's John Smith ordered at this date and ordered also another date. So this is not unique, and this attribute of customer name. Likewise, it follows with the street, city, state, and zip, huh? Because that's the street, city, zip, and state of the customer. Likewise with the ship date. And customer ID, it may be confusing here. We know that in the previous table the customer ID is a primary key, but in this case uh, the customer ID can appear as many times uh, as the many times of as many of order number. So in this case 30016 and 30016, that's not unique. So what uniquely identifies a certain record in an order table would be the order number. Okay, so let's go to our Lucid software. So here would this would be the primary key. Okay, and the rest would be deleted, of course, because there should be only one uh, primary key here. Okay, so in the product ID or the product table, and the product table, let's consider product table. What's the product table? There you go. So the quantity can appear uh, uh, the same among the various product ID. The product type can also be ordered as many times for different customers. So therefore, the product ID would be the primary key, and this entity of the product or the product table. So this would be our primary key. Consider another type of key. Key is the same as the primary key from other entity, and it is used to reference that entity. Note that don't need to be unique and can be repeated in various attributes. So in this case, um, um, we want to know the foreign key in the order table by examining the attributes. So notice that customer ID is repeated in the other table to order. So the customer ID from the customer entity is repeated in the order table or entity here. So what does that mean? Um, that the order table is actually referencing to the uh, customer ID. Mm. So what do you mean by that? Because we want to know the specific order or to which order is actually uh, the owner of that order. No, what I mean, we want to be sure that that order is uh, the exact order of specific customer on the customer table. So we are actually referencing the customer ID of the customer table to the order table. So take note that that primary key is the same as the primary key in the other table, but it is now called as the foreign key. No? So, so we would just want to make sure that a specific order is uh, actually going to the right person or right customer ID in the customer table. So that's why we consider this as the foreign key. Um, okay, let's note that it can be repeated. So, so in this case, it is repeated because foreign key here, we have the customer ID is being referenced by the customer ID of the customer table to the order table. Likewise, with the product ID, this will be a foreign key, which is the same as the primary key of the product. So, it is actually referencing that product ID to this order. So that order belongs to this product ID. Okay? So that's it. So that is what I mean by foreign key. So looking at the order table, for example, by see again the John Smith. So in the order table, we have the customer ID. So this is the order 252349930 ordered by John Smith, and we know that that order was placed by John Smith because of we know that 30016 is the customer ID. So uh, in the customer table, then we know that 30016 um, what is the 30016 here? Oh, sorry. There you go. That an order was made, and that order was placed by John Smith, 30016. Okay. So 30016. So what's the order of John Smith? 30016. Um, Customer ID 30016, and that order was made by John Smith. Likewise, he also ordered another order. Okay, of one in this case. Okay. So unlike primary key, the foreign key in this case can be repeated. Like for example, in the order table 30016 is repeated. That John Smith ordered an item here or an order, and then at other date he also ordered another with an order number 30016 as a foreign key. So there can be as many repeating same um, customer ID, and that is actually the reference to the one who placed the order in the customer table, which is John Smith by the 30016. Okay. So foreign key can be repeated but with different product. uh. So in this case, we can actually add the product ID. um, and the ERD. So since the product here has a product ID and a foreign key can appear as many times, no? In this case, this is the foreign key of this order referencing to the customer ID also in the customer table. Likewise, if John Smith ordered two different product and we want to know what specific product, so the order number of what specific product. So by copying the same product ID, of course, referencing the product ID in the order from the product table. So we could actually add here another attribute. So that is product ID, and variable type is integer, and we know the fact that this product ID also appears in the product table. So this primary key of product ID would be the foreign key to the order number. Foreign key. Yeah. So we could now move the relationship of this to relate the in between the tables, no? To relate in between the tables. So we can now move this. So I mean to say we can now move this. Oops, sorry. Oh. Undo. Okay. Okay. Oops, I'm sorry. So okay, so we can now move this. Oops. Why is it not moving? So the customer ID is actually the same customer ID here. Likewise here, select and move that the product ID is the reference attribute to the foreign key of the order. There you go. So that's how we relate the tables or the entities, considering the primary key and foreign key.